Hi everyone, my name is Adam Dede and thanks for joining me on this edition of my Neuro Journal Club. And here today we're going to talk about an encephalographic study on the Zen meditation, also known as zazen, by Kasamatsu and Hirai from 1966. So this is kind of an old paper, but this is really a bit of a classic in terms of the physiological study of meditation and really one of the first studies to actually look at meditation from a physiological standpoint, which I think is a really big deal in trying to bring this kind of nebulous thing that's very difficult to observe as it happens internally within someone's head. How do we actually observe that as something that can be scientifically quantified? And so I think Aziz is going to try and knock over my computer. I think that this study is really kind of a landmark in bringing that into scientific realm. So let's take a look. So first, let's try and define some terms. So what is Zen meditation? So in Zen meditation, hold on, we got a cat problem. Come here. So in Zen meditation, one sits either in full lotus or half lotus, and these are the figures from the paper. And for anyone who doesn't know, half lotus is this position over here where one is sitting in a cross-legged posture and has one foot up on the opposite hip, and then full lotus is where both feet are up on the opposite hip. In addition, in Zen meditation, one holds one's hands like so, and you can see that pictured here. In addition, the eyes are kept open, which is different from some types of meditation. The gaze is directed down about 1 meter in front of the meditator. The gaze is relaxed and unfocused, and the mind is held in the present moment, which is definitely the most nebulous piece of the description. So the mental state that's being shot for is described in the paper as this. This mental state of satori or enlightenment will often be misunderstood as trance or hypnosis. It is said that satori is not an abnormal mental state, but one's everyday mind in the Zen sense. Dr. Eric Fromm describes, if we would try to express enlightenment in psychological terms, I would say that it is a state in which the person is completely tuned to the reality outside and inside of him, a state in which he is fully aware of it and grasps it. He is aware of it, that is, not his brain nor any other part of his organism, but he, the whole man. He is aware of it, not as of an object over there, which he grasps with his thought, but it, the flower, the dog, the man, in its or his full reality. He who awakes is open and responsive to the world, and he can be open and responsive because he has given up holding on to himself as a thing, and thus has become empty and ready to receive. To be enlightened means the full awakening of the total personality to reality. So that's all a pretty tall order and is a little bit nebulous, really. I mean, it sounds really interesting, but it's really difficult to define, and it's also really difficult to define when an individual may or may not be experiencing this kind of a state. So instead, Kasamatsu and Hirai turned to EEG as a way to try and quantify what's actually going on. This was their setup. They had Zen disciples and priests meditating in their home temple. And you can see pictured here is a Zen disciple with EEG leads attached to his head. And they did a really minimal EEG setup. And the reason they say they want to do that is so that they don't interfere with the meditation. They split their meditators into 3 different groups based on how long they'd been meditating. They had 20 disciples who had been meditating for between 1 and 5 years, 12 who'd been meditating for between 5 and 20 years, and 16 priests who'd been meditating for over 20 years. So pretty experienced meditators. And the majority of the paper then goes through showing you the raw EEG traces from one of those highly experienced priests. So let's take a look. So first they show us that there's normal low amplitude non-correlated activity before meditation begins. And this is going to be basically the same figure we're going to be looking at throughout. There's a frontal lead, a central lead, a parietal lead, an occipital lead, and then they also show us the subtraction of parietal minus occipital. Down here we have a scale bar. This is indicating 50 microvolts in the vertical and 1 second in the horizontal. Quickly after this particular meditator begins meditating, we can see 50 seconds in, indicated here in the top right, we have these fairly large amplitude correlated oscillations that are going on. And this is alpha activity. As we saw in the last Neuro Journal Club video, it's these pretty rhythmic oscillations that seem to occur at roughly 8 to 12 cycles per second. In this case, these are about 9 or 10 cycles per second, which is really pretty typical. You can see also here a really typical feature of the alpha oscillation, which is that the amplitude waxes and wanes. So here over on the left side of the figure, we can see an area with fairly large amplitude alpha oscillations, kind of wanes away, and then waxes back in this kind of amplitude modulation. So there's this kind of overriding rhythm to the rhythm, as it were, in terms of that amplitude modulation. Now, one thing that's really different about this oscillation that we're viewing here versus the classic alpha oscillation are two things. One, we're seeing that this is happening more at frontal sites than occipital sites, which is exactly the opposite of what's typically seen. And then also we're seeing that this is happening with the eyes open, which is different from the classical observation of the alpha rhythm. So just to unpack that a little bit, here's a figure showing us alpha oscillations in kind of the classic eyes closed situation. And here they're recording with quite a few more electrodes than the Kasamatsu and Hirai study. And we can see here all of the traces that they recorded from this setup. And I've gone ahead and done some color coding for us. So I've just color coded this as red, being pretty strong alpha oscillations. You can see these two traces are pretty large amplitude alpha oscillations. And I should say the dashed lines, as opposed to the dotted lines, the dashed lines are showing us 1 second increments. So if we wanted to, we could take a look: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 peaks in a 1 second period. So indeed, we are looking at a 10 hertz oscillation. But yeah, I've just gone ahead and color coded the amplitude, and you can see we've got a couple here that are really strong. And then in orange are the ones that I'm kind of arbitrarily saying are kind of in a middle range. And then in yellow, these ones are smaller. And then anything that's not highlighted, I'm kind of deeming that as something where you really can't see too much of an alpha oscillation with the naked eye. Now, this is obviously a very rough measurement, by no means a quantitative measurement, but it gives us a little bit of an idea. Now, in this set of traces, they didn't show us the results from the central line electrodes, CZ, PZ, and OZ. But I'm just going ahead and inferring, based on kind of a rough averaging of what's next to these electrodes, that this might be something like what we would see. And so when we compare this now to what's seen in the case of Zen meditation, we see something really quite different. So where the classic alpha oscillation is something that's really posterior, and again, it's with the eyes closed. Maybe there's a little bit of right lateralization, maybe not. There have been other reports that seem to show that it is a little bit right lateralized. But then in the case of Zen, the Zen alpha, we see that it's really a frontal phenomenon that gets weaker and weaker as we go towards the occipital electrodes. So something really pretty different is going on compared to classic alpha. And then if we take a look at what happens to alpha as the meditation continues, so up here we're taking a look at the meditator 50 seconds into his meditation. The middle two traces are just showing you the frontal and central electrodes at 8 minutes and 20 seconds in. And then again, we're looking at those same two frontal and central electrodes at 27 minutes and 10 seconds in. And if you just kind of take a look at this with kind of a gestalt eye, you can see that the amplitude of the oscillations is kind of getting larger as we go. And in addition, the period of the oscillation is getting longer, so the frequency is reducing somewhat. And in the text, they note that we're moving from about a 10 hertz oscillation here down to about an 8 or a 9 hertz oscillation down here. Just 20 seconds after the last trace that we saw in the previous figure, this new phenomenon emerges of these theta oscillations. Now, theta is defined as an oscillation in about the 6 to 8 hertz range, as opposed to alpha being about the 8 to 12 hertz range. Now, these binnings are a little bit arbitrary, but there has been some evidence that they actually have different ontogeny in terms of the neural generators that give rise to them. So that's why this ends up being something of interest. And you can see here that these are quite different from the oscillations that we were seeing before. Rather than being sustained in the way that the alpha oscillation appears to be, these seem to come in bursts. Also, you can see here, just like the alpha oscillation, these are more frontal than they are parietal and occipital. We can also see that they are a bit slower, and that frequency is really the most important thing in categorizing these as a theta oscillation as opposed to an alpha oscillation. And then after the meditation was over, it turns out that the alpha oscillations actually persist. And again, this is with the eyes open, which is really quite different from the classic observation of the alpha oscillation. So they summarized their group findings in the following way. So they staged their meditators. They asked, what in this kind of progression of EEG changes was the highest level that any particular meditator achieved. Where stage 1 was a slight change, which is characterized by the appearance of alpha waves in spite of opened eyes. Stage 2 was an increase in the amplitude of the persistent alpha waves. Stage 3 was a decrease in the frequency. Stage 4 was the appearance of the rhythmical theta train, which is the final change of EEG during Zen meditation, but does not always occur. And I'd say actually none of these really always occur. If we take a look at their summary table down here, we can see that as a function of the years that one has spent meditating, one seems to make it further and further into this stage system. But really, there's a good number of meditators that really never make it out of that stage 1, especially in the beginner group. So what can we say summarizing the brain changes with Zen? So alpha activity seems to increase even with the open eyes. Alpha activity is predominantly frontal, and eventually theta appears in high-level practitioners. And they had no report of anybody falling asleep in this particular study, which is kind of key because alpha oscillations have often been associated with kind of a drowsy, not really active state. And so the possibility arises that maybe meditation is just kind of low-level sleep of some kind. But at least in this study, they had no reports of anybody falling asleep. So that seems to suggest that something kind of different is going on. And then just to do a bit more of direct comparing, alpha is different in the classic eyes closed condition versus in Zen. So we saw that the scalp distribution was different. We also saw that in classic alpha, it's associated with a loss of attention, whereas in Zen meditation, it's associated with increased attention. So this gives rise to the question, are there different kinds of alpha? And that was really the same question that we got left with last time in thinking about biofeedback and this weird juxtaposition that it's possible for somebody to not be able to detect when they are or are not in a state of high alpha, but yet they may be able to control whether they are or are not in a state of high alpha. So it would be interesting, although I don't know, if there are actually differences in these particular meditators between their endogenously created alpha oscillations that you may see when they're falling asleep or when their eyes are closed or when they're relaxed versus these alpha oscillations that you see when they're concentrated and meditating. But to my knowledge, there isn't any good comparison of that here. But anyway, big take-home points. You can see pretty dramatic brain changes as measured by EEG in people as they meditate. These differences seem to really progress with one's experience in meditation all the way out to people who have been meditating for more than 20 years. And this gives us this kind of lingering question of, are there different kinds of alpha oscillations? And if so, what do they mean? So hopefully we'll be able to get into some of those questions in future videos. But for now, thanks for watching. And if you liked it and want more, please go ahead and subscribe. Thanks.